I want to do one more quick example. So the way this is graphed, it's all in terms of passes. So this is the recall for students that pass and the false positive rate for students that pass. But we can actually test it on the other class. All we have to do is take the predicted probability for fails. So that's going to be the first column. And then with this keyword argument positive label, or POS underscore label, we can identify which classes we should call the positive. And so if we call 0 the positive, that's a fail, right? 0 in our data represents fail. So now we can generate this plot for the case where we're trying to, or sorry, we can generate this plot in terms of fails. So the recall is now identifying, the most fails, correctly identifying the percentage of actual fails, and then a false positive rate is the percentage of students that actually passed that we predicted would fail. So let's say, you were okay with maybe the threshold up here where our recall is almost 0.8. Our recall is, yes, almost 0.8. And our false positive rate is 0.6. So that would be this. If we go up here, we could see where the recall is 0.76. That's the 1, 2, 3, 4, 5, 6 value. So the recall is about 0.76, and the false positive rate is about 0.6. So let's see, 1, 2, 3, 5, 6. Yep. So the 6 value. So if we look at the thresholds, that's 1, 2, 3. That's a decision threshold of 0.27. We're saying any time the model predicts a probability of failing that is above 0.27, we'll call it a fail. And you might want to do that if you're, this is a completely made up scenario, but let's say you to assign special attention to these students and you're okay, you say, okay, I want to make sure I capture as many of the students that are at a high risk for failing as I can. So I'm okay with capturing, almost 80%, even if also about 60% of the students that will pass anyways are also going to receive extra attention. Right, that's one way you could interpret it. Okay, I think that's enough on ROC curves. On thresholds, I think, the main point here is that you don't have to use the 0.5 threshold. Sometimes it does not make sense. So I always come back to the shipping food across the country because I've worked with that. It really doesn't make sense, right? It doesn't make sense to have that balance. You actually want to be erroring on the side of identifying those shipments that are going to spoil, because that's what makes sense in the business case, right? That's what's actually going to save you money and save your product. So I'm sure you could think of other applications, maybe your own work, where you want that imbalance trade-off. All right, we're almost done this week. The next lecture, we will talk about how you can save models you have trained so that you can load them in other Python code and use them to make predictions. All right, welcome back. This will be a quick lecture. This is just about how do you, we've trained a model, right? We've trained logistic regression models. So let's say we actually wanted to save this so we can load it later in other code and use it again. We can do that. So scikit-learn has this job lib submodule, which has these dump and load functions, and we imported job lib above, top of the notebook. And all you need to do is just call the dump method and pass to it the object or the model that you'd like to dump. So here I'm dumping best tree, and then where you'd like to put it. So I've just made a save path, which is in the current working directory, and the file name will be tree_model.pkl. So the .pkl it's saving these as pickle files, which you don't need to know about, but it's just a way to save data structures from Python. So the .pkl stands for pickle. And you just save it. So you can run this code. This will save it. And then we can load it using joblib.load, and you just point it to the file path. So here I'm saving it, and then I'm loading it back in as a different variable, and then I'm using it to make predictions, just to prove that it works. Now, of course, you wouldn't save it and then load it in the same code. I mean, most of, maybe there's some weird example where you would, but most of the time you're not doing this. You're actually saving it here and then loading it in like a different notebook or a different script, which you could 100% do. I'm just doing this to show you that works. All right, that's it for this week. If you love decision trees, I just put some next steps in here. These are not required for the course at all, but if you really like this, and I mentioned how decision trees are used quite a bit, then here are some resources that you can use. Scikit-learn itself has a lot of examples that you can work through. And then once you work through those, you can look at the random forest classifier, which is an ensemble of decision trees. And then after you work through those, and this will take some time, you could check out the H2O library, which is a different library other than scikit-learn, but it has some more advanced implementations of decision trees. All right, very good job this week. I know it was a lot, and I will see you next week.